Today we're going to be learning about arc length and sector area. So we started our trig unit circular functions yesterday, and we talked about angles, both in degrees and radians. And we're going to do some basic geometry today. Basic geometry. So things that you should already be familiar with, these words. You should know what a sector is. A sector is like a slice of pie. You should know the center of a circle. You should know what a radius of a circle is. You should know what a chord is. And chord is any line that goes from edge to edge of the circle without being the diameter. And lastly, an arc. An arc is literally a piece of a circle, just a piece of it. And the reason why center is spelled that way is because international mindedness. Lots of other countries, that speak English spell center that way, and they spell color differently than us, and you know. Just saying, they say aluminium instead of aluminum, you know, things like that. They say crevasse instead of crevice, glacier instead of glacier, you know. Anyway, yeah, that's how center is spelled in other versions of English. Yes. Yeah, gray spelled with an E or an A, like yeah. International mindedness. I said that. Okay. We can describe arcs, sectors, and segments as major or minor. And that literally just means, was it more or less than half of the circle? Minor means less than half the circle, major means more than half the circle. Of course, exactly half a circle would be called semicircle. Okay. It's kind of hard to see in this picture, so I'll shade it in, but you have a chord here, and this segment is shaded. It's a minor segment because it's less than half of the circle. And it's impossible to see on this one, but there are points here and here, and you have major arc AB because it goes more than halfway around the circle, and then you have minor arc AB because it's less than half the circle. Not too bad, right? Easy peasy lemon squeezy. Arcs are a piece of the edge of the circle. And since the length of a circle is also known as its circumference, which is also known as circumference, we can divide the length of that circle into pieces and create arcs with known lengths. So that's literally how you find the arc length. You would take the perimeter, also known as circumference, 2 pi r, and you could then divide it by whatever fraction of the circle your central angle theta gives you. In degrees, that formula looks like this. And this and this are basically the same thing, because when I said divide this into pieces, then it's this formula. Because theta over 360 literally says a fraction of a circle's circumference. See? So this would be your circumference if your theta was 360, because you'd have 360 over 360. But the point is, if your theta is, let's say, 90 degrees, you know, that's a quarter of the circle. So you could either do 2 pi r divided by 4, because you realized that 90 was 1/4 of the circle, or you could just do 90 divided by 360, which is 1 divided by 4, times 2 pi r. Bad news, though. That formula is not in the reference sheet. This formula is, though, r theta. R theta is an arc length, but only if you're working in radians. So for this one, theta has to be radians. So if I give you degrees and you don't have this formula memorized, then you're going to have to use yesterday's knowledge and convert it to radians. That's just r theta. R theta is our friend. Radians are our friends. Sector area, or the area of this pie slice, is found using the exact same logic. You would take the area of the circle, which is pi r squared, and you would literally divide it by whatever fraction of a circle this theta is. So if this theta, again, was 90 degrees, that would be 90 over 360, which is 1/4 of the area. Or you could use this formula that's in the reference sheet, 1/2 theta r squared. I just like the radian formulas. They're less to memorize, and I do try to memorize the formulas. It's faster than digging through the reference sheet. And it shouldn't be too difficult for you to see why this formula is the way it is, as long as you know how to convert radians to degrees. Notice that this formula doesn't have a pi in it, but this one does. That's because pi radians represents 180 degrees. This 1/2 is coming from the fact that we can throw 180 degrees over pi in for theta, and you would get this formula. So that's where the 1/2 is coming from. Anyway, arc length, I say r theta, theta r, whatever. Sector area, 1/2 theta r squared. Boom, they're in the reference sheet, ready to rock and roll. We have 3 questions to do today. I might add a 4th. Sector has a radius of 12 centimeters and an angle of 3 radians. I'm going to draw that. Picture not drawn to scale because I have no idea what 3 radians would look like. Well, I guess it's just a little bit less than pi, right? So picture ridiculous and not drawn to scale. This would be almost half a circle. Here we have 3 radians. By the way, seeing a superscript c is another way of seeing radians. Why? I don't know. To be honest with you, I don't know. But I want you to know that that means radians also. I could have just written 3 and it would have meant radians. As long as it's not a little circle that means degrees, it's automatically radians. And we know that the radius is 12. Let's find the length of the circle, the length of the arc. L equals r theta in radians. Lucky for us, theta is radians. So L is 12 times 3. Oh, 36. That was easy. So that arc length is 36 centimeters. IB doesn't really care much about units. Looks like you have a question. Ask. Huh? 3 radians is an angle. It's almost 180 degrees. Just write 3. Because if there's no degree symbol, it's assumed that it's in radians. Because the radius was 12. If it said 6 radians, you do 12 times 6, yeah. If it's in degrees, you got to work a little bit harder, don't you? Radians are our friends. I would. The quicker you can get used to radians, the faster it is going to be, the faster you will be at learning trigonometry, which is coming up very, 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 very soon. Let's find the area of this sector. area is 1/2 theta r squared since we're in radians. So our area is 1/2, our theta is 3, and our r is 12. Oh boy, let's see. 12 squared is 144. 144 cut in half is 72. 72 times 3 is 216. There you go. Square centimeters. You know, the question didn't ask for it, but I'm going to go ahead and throw a question C on there. And it's going to say find the area of the segment. And recalling from the previous page, the segment is this. I think I know why it's not in these notes now that I wrote it. Yeah, never mind. You're not ready for it yet. You need to know a little bit of trig to pull it off. That's why it's not in these notes. It'll be in future notes though. Sorry. Now the real question is, when does it show up? Tell you what we're going to do. I'm going to create a question after we answer this next one so that we can find the area of that segment without using trigonometry, okay? Because I do want you to know how to do it. I want you having those thought processes now. But before we get to that, it says find the area of a sector with this radius and this arc length. Oh, I was given an arc length, not a theta. But we can find theta, can't we? Because arc length is r theta. I know the radius is 8.2, and I know length is 13.3. This theta must be in radians because I used r theta. Grab my calculator. Just happen to have this one on my desk. 13. Eek is ugly. Using this formula implies the answer is in radians. You mean the calculator? All I did was division, so the calculator doesn't differentiate between degrees and radians. Now, if I was doing any kind of trigonometry, then yes, I would need to put this calculator in radian mode. But 8.2 or 13.3 divided by 8.2 is the same answer in degrees or radians. It's 1.622. But yes, normally you would need to pay attention to that. 1.622 is 4 sig figs, so we know that that's allowed. And then it says to find the area. Area is 1/2 theta r squared. Our theta, which is 1.622 times 8.2 quantity squared. And guess what? My calculator still has that number sitting on the screen. So I don't even have to round. I'm just going to say divided by 2 times 8.2 times 8.2. Well, I would have if I hadn't typed 0.8. Got to clear it all. Urgh. I got an idea. 8.2 squared divided by 2 equals times 13.3 divided by 8.2 is there. 44.22. Easy peasy. And before we call the notes finished, let's find the area of the sector. Not sector, segment. I feel like I've misspoken in this video. Said words I didn't mean to say more than I've ever said in my life. Find the area of the segment. I'm going to draw you a shape. Give me a radius for the circle, not 1. That's boring. I'm gonna do 4. Well, I wanted you to know that that was 90 degrees because we can do this without trig now. You're gonna find the area of segment AB. That means this. Find the area of that thing. How could we possibly do that? If we're trying to find the area, what about the triangle? If you find the area of the whole sector, and then subtract the area of the triangle. So the segments area is the sector area minus the area of the triangle. Literally, this thing is equal to this thing minus this. So you just find and actually when I was a geometry teacher, I would write it like this. Area subshape, area subshape, area subshape, meaning area of this thing is area of this thing minus area of this thing. That's what I used to do for my geometry students. So we need to find the area of the sector. And I'm going to be real with you. I want to use r theta. So I don't want this in degrees. I want it in radians. What is it in radians? It's pi over 2. So this is pi over 2 radians. My area then for my sector is 1/2 theta r squared. That's going to give me 16 divided by 4. It's going to be 4 pi. Anybody see a quick way of getting to that answer, 4 pi? Why don't you just do pi r squared divided by 4? I mean, that is what it is, right? Pi r squared, the area of the circle. This is 1/4 of the circle. Just getting there a little bit faster. But that's me using the formula. And the area of the triangle. How do you find the area of a triangle? 1/2 base times height. By definition, base and height are perpendicular to one another. So if it's a right triangle, it's just the 2 legs. So it's 8. The area of the sector then, the area of sector AB is just 4 pi minus 8. That's it. Because I can't remember if you have to do that kind of stuff in your homework or not, and that's why it's in these notes. And that is it.